What's up, everybody? It's Miss Brothers. So this is the third page of the Chem Quest that we did last week, and these are some problems that went with it. And I decided to wait to introduce these problems because I wanted to be able to go through just some basic thermal energy problems before we went to problems where you were going to be using the triangle to manipulate the problems a little bit. So let's just go through these again. I'm going to walk through them just kind of using the process that we established. And again, if you'd like more information on that process that I'm talking about, you'll go to the daily notebook and look at slide 35. And if you're not sure what that is, please email me and ask me. I can show you. It's pretty straightforward. It's right on Google Classroom, and I move it to each new topic as we get to the day. Okay, so let's start with question 1. It says, what is the temperature change of a 120-gram piece of aluminum whose specific heat is 1.89 joules over grams degrees Celsius after 1,800 joules of heat energy is applied? So unlike the other problems that we did where we were solving for Q, this time we're actually going to be solving for the change in temperature. Now before we get going, just a couple of reminders. When we're doing these thermal energy problems, thermal energy is represented as Q, and that equals our thermal energy. We have specific heat, which is represented CP, and I'm just writing this up here as a reminder. We have mass, which is the M for mass, and finally we have the delta T, which if you recall means delta is the triangle, and delta means a change in something. In this case, it's the change in temperature. Okay. Now, normally, if we were trying to find change in temperature, we would use that formula TF minus TI, but we're not given that information in this problem. What we are given information on is the energy, the mass, and the specific heat. So we know that we are looking for, because it says right here at the very beginning, what is the temperature change of a 120-gram piece of aluminum? So we're trying to find the temperature change. So we want to find delta T. And if we're going to do that, we can go ahead and bust out our little triangle here. And this time, because we don't know the change in temperature, we can cover that up, and we end up with Q divided by, or Q over, mass times our specific heat. So that's the formula that we're going to write. Q over M times CP. So let's go ahead and do that. So change in temperature equals Q over mass times our specific heat. So let's take a second and let's figure out if we have everything we need, all of our numbers, to put into this formula. So Q, there it is, 1,800 joules of heat energy. Oops, that needs to be a capital J. Over my mass, there it is, 120 grams, times my specific heat. Look, there it is right there, specific heat, 1.89 joules over grams degrees Celsius. So now I can start doing a little bit of math here. Now I want to remember that when it comes to doing this problem, I want to make sure I do my multiplication at the bottom of the formula first. So let's go ahead and do that. We're going to take 120 grams times 1.89 joules over grams degrees Celsius, and we end up with 200. Well, let's go ahead and set that up. 1,800 joules divided by 226.8. And as far as what units are going to go here, I can go ahead and just go ahead and cancel out my grams, and that leaves me with joules over degrees Celsius. So now I can go ahead and do the math here to solve for the change in temperature. And I'm going to take 1,800 divided by 226.8 joules over degrees Celsius. Now what happens is that I can cancel out joules, and if I do the algebra here, that moves degrees Celsius to the top, so then I end up with 7.9, and then again degrees Celsius because I'm trying to find change in temperature, and then finally I go ahead and circle my final answer. So as far as my process, I figured out what I needed to solve for, change in temperature. I figured out my formula using my density, or my specific heat triangle. Then I set it up to make sure that I had all the numbers. I did my multiplication down here at the bottom. Then I took my 1800 joules of energy, divided it by 226.8, and I end up with 7.9 degrees Celsius. All right, let's go to the next question, question 13, because we're going to have to do a little something different on this question. So it says a beaker containing 250 grams of water is heated with 1,500 joules of heat energy. So right off the bat, I know I have my mass and I know I have my Q. If the temperature of the water changed from 22.0000 degrees Celsius to 23.4354 degrees Celsius, what is the specific heat? So I know right off the bat, I'm trying to find the specific heat. So I know that specific heat is Cp. So I'm trying to find Cp equals something. So let's go ahead and get our triangle again. And let's go ahead and cover up what we don't know. We do not know the specific heat. So we're going to cover that up. And what's left is Q divided by, or Q over, mass times the change in temperature. So when I set that up, it's going to be Q over M times delta T. So let's set that up. Specific heat equals Q over M times delta T, or Q over mass times the change in temperature. So let's take a minute and let's figure out our change in temperature. Now, if you recall, change in temperature equals my TF, or my final temperature, minus my TI, otherwise known as my starting temperature. So in this case, if I'm looking at my problem, and you guys, you don't have to write this every time. You don't have to write delta T equals TF minus TI. I do that just to remind you what the formula is so you remember the process. So let's go up here and look at our temperature data. It says the temperature was changed from 22.0000 degrees Celsius, so that's my initial temperature, to 23.4354 degrees Celsius, which is my final temperature. So to put these into this equation, I'm going to take my final temperature, 23.4354 degrees Celsius, minus 22, because that's my TI, 1, 2, 3, 4 degrees Celsius. And if I do the math on that, 23.4354 minus 22, that's going to equal 1.4354 degrees Celsius. So now I have everything I need to solve this problem. I have my Q, which is 1,500. I have my mass, which is 250. And I have my change in temperature, which is 1.4354 degrees Celsius. Let's go ahead and set up our problem. So I have 1,500 joules over 250 grams, or 250.0 grams, times 1.4354 degrees Celsius. So I'm going to go ahead and do my multiplication down here first. So that's going to be 250 times 1.4354. That's going to be 358.85 grams degrees Celsius. So let's go ahead and do this over here so it's a little bit cleaner. It's going to be 1,500 joules, boop, over 358.85 grams degrees Celsius. So let's see how we do with the math here. So we're going to take 1,500 divided by 358.85, and that leaves us with 4.18. And again, we're doing specific heat, so we have to include all of our units here, joules over grams degrees Celsius, and that's going to be my final answer. Okay. And if you have trouble with the units, really what you have to remember is go back to that document, the 14 things that you need to remember about specific heat and thermal energy, and it'll just remind you that this is the unit, this whole big thing is the unit for specific heat. So that's problem number 2. So far, so good. Let's do this last one. Now, this last one is 2 parts, and so we'll need to remember the first part if we're going to do the second part, so keep that in mind. So let's go through our process, and let's do 14a together. It says heat equal to 2,500 joules, so we have our heat energy right there, is applied to a 1,200 gram brick. 1,200 grams, that's our mass, whose specific heat is 2.54 joules grams degrees Celsius. So what is the change in temperature of the brick? Well, that reminds me of this first problem we did because we had to find change in temperature there. So change in temperature equals, and if you recall, this is what we did when we took our triangle. We were trying to find the change in temperature, so we covered it up, and we ended up with Q divided by M times Cp, or energy divided by mass times specific heat. So we're going to set up our formula, Q over M times C. Let's do that. Q over my mass times my specific heat, which is that big C, little p. Now let's figure out if we have everything we need to solve for change in heat. Do we have our energy? Yes, we do, 2,500 or 25,000 joules. Do we have our mass? Yes, we have a 1,200 gram brick. And do we have our specific heat? Yep, it says so right here, whose specific heat is 2.45 joules divided by grams degrees Celsius. So let's go ahead and put our numbers in. Let's see what this gets us. So there's 25,000 joules over my mass, which is 1,200 grams, times my specific heat, which is 2.45 joules over grams degrees Celsius. Now again, if I want to, I can go ahead and cancel out my grams right now as I do this multiplication first. So I'm going to just get started on this over here. So I know that I've got 1,200 grams times 2.45. That leaves me 2,940. And since I've already gotten rid of these over here, that's going to make this joules over degrees Celsius. So now I have to finish this. So I'm going to take change in T equals, it's going to be 25,000 divided by 2,940. So let's go ahead and do that math. 25, 1, 2, 3, divided by 2,940. That equals 8, and we'll just go ahead and round that to 8.5 degrees Celsius. Because again, I can cancel out my joules, and if I do the algebra here, I can go ahead and move that C to the top, which leaves change in temperature of 8.5 degrees Celsius. So now, it says if the brick was originally or initially at a temperature of 25 degrees Celsius, what is the final temperature of the brick? All right, so if we have our formula, change in T equals TF minus TI, then what this also tells me, if I'm trying to find the final temperature, and if I do the algebra, what it's going to mean TF equals my TI plus my change in temperature. Okay, so what this tells me is that TF equals my TI, and what we figured out was that the initial temperature, it says right here, is 25.0 degrees Celsius, plus my change in temperature, there it is right there, 8.5 degrees Celsius. So my TF, if I do my addition here, is going to be 33.5 degrees Celsius. And that's going to be my final answer. So all I did was to take my change in temperature and simply add it to my initial temperature. Okay? And one of the things you have to remember is that we knew we were going to add this up because it says energy is applied. So if energy is applied to something, we can expect the temperature of that object or that substance to rise, and we see that right here, that our change in temperature, we actually got warmer by 8.5 degrees Celsius. So there you go. We took information from this problem, and we fed it into this problem, and we figured out where our final temperature would be. All right, guys, so if you have any questions on how to do this particular set, again, what we did differently in this one is that, compared to our first practice, is that we spent a lot more time sort of manipulating and using the triangle. In our first set of practice, we really just used this one where we were looking for the energy needed, and we ended up using this multiplication formula, where in this one, we manipulated the formula a couple of different ways. We manipulated it so we could find the change in temperature a couple of times by taking Q divided by mass times specific heat. And then one different time, we also found the specific heat by taking our energy and dividing that by mass times the change in temperature. So we did a couple of different things that we had to manipulate our triangle, but we did it, and we were successful. All right, guys, if you have any questions, let me know. Have a great day.